Good day, everyone. I'm Archibald B. Claro, together with my group mates Mabayaw, Pitalcorin, Nistal, and Morgia. So our topic is all about test of randomness. When we say random, it occurs without a specific pattern, meaning without prearrangement. So in this topic, we will learn how to test a series of events if it occurs randomly or it has a pattern. So let's start. The Rand's test, or the test for randomness, sometimes called a Wolfowitz-Rand's test, it is a statistical procedure for examining a series of events for randomness. The Rand test seeks to determine if a series of events occur randomly or merely due to chance, meaning if the series of events ba is random ba siya or na siya'y pattern. So, take note that the series of events there is sequence of events. The rand test is only applicable to binary data or categorical data, meaning, for example, we have male and female. Uh, M for male and F for female. That is the categorical data. So to test the series of events if it is random or not, let's identify, this is the first step. Identify the number of runs. Now, runs denoted as R. A run is a sequence of the same event written one or more times. Take note the same events written one or more times. Meaning you can calculate the number of runs by counting the number of times the value changes. The value changes. So, to have a better understanding, let's have an example. So we have here a categorical data. We have a two category, which is the heads, H for heads and T for tails. Now I have here a series of events. So imagine if I'm going to flip a coin and nagiging head. The result is heads, and the second is tails. The third flip is tails, and the fourth flip, the result is heads, and the fifth flip is the result is tails. So how to identify the number of runs? Since we already have the series of events here. So to identify the number of runs, so let's count now. H, this is our first event. Since H, H, it is considered our first run. Now, first run. And next is T, right? As you can see, the third flip and the third result is also T. So we have same event written one or more times. Written two times ito. So meaning, it considered as 1. So meaning, ika-second run to. Itong dalawa. Second run. Next, nag-change na naman ulit. So we have heads here. So meaning, itong si heads magiging ka-third run. Ito naman si tails, nag-change na naman. So magiging fourth run. So meaning, therefore, the number of runs in our series of events, we have four. Four runs. So that's how to identify the number of runs. Now, let's have n sub 1. Sorry, it is not n1. It should be n sub 1. Ito. N sub 1 is the number of times the first event occurred. In this series of events, our first event occurred is the heads, right? Ito, heads. This is our first event. Now, let's count how many heads occurred. So we have 1 and 2, meaning our n1 here is 2. Now, n sub 2, na naman, to identify the n sub 2, same lang. But this time, the second event. Our second event here is the tails, right? Since it occurred the second, let's count kapila nag-occur si tails. So we have 1, 2, and 3. Therefore, our n sub 2 is 3. That's how to identify the n sub 1 and n sub 2. Now, since we already know how to identify the number of runs, the n sub 1 and n sub 2, let's have uh, a sample problem for small data. Sample runs test, small data samples. So I have here sample problem. A male science teacher was observed during a typical class discussion. The observer noted the gender of the students that the teacher called on to answer a question. In the course of 15 minutes, the teacher called on 10 males and 10 females. The observer noticed that the science teacher called on equal numbers of males and females, but he wanted to examine the data for a pattern. To determine if the teacher used a random order to call on students with regard to gender, he used a Rand's test for randomness, using M for male and F for female. The sequence of events recognition by the teacher is M, F F, M F, M F, M, F F, M, F F F, M M F, M M M. So this is our series of events. And again, the observer wants to know if this series of events occur randomly or not. So let's test for randomness runs test. So first, let's have our null hypothesis. Our null hypothesis is the sequence in which the teacher calls on males and females is random. And our alternative hypothesis is the sequence in which the teacher calls on males and females is not random. Now, take note that our alpha value that we're going to use is A is equal to 0.05. Now, to our problem, we have two categories, which is the male and the female. Now, this is gikapin ako ang series of events from the problem. Now, let's test if it is random or not. First, let's identify the number of runs by counting it. So, M is the first run. Female and female, it considered 1 since parehas raman silang duha. So it considered the second run. So nag-change na naman siya into male. So magiging third run. And nag-change naman siya into female. We have fourth one. And ito naman, nag-change naman siya into male. So fifth run. And female naman, nag-change naman. So sixth run. Change na naman siya ulit into male. So we have seventh run. Ito naman, change naman to female, but this time, same gyapon, nag-occurs 2 times. Same gyapon siya, di ba? So, it considered as 1, so magiging 8. Ito, ika-8 run. Ito naman, si male, magiging 9th run. Ito, parehas naman ni si tulo ka female. So, it considered as 1, so magiging 10th run. Ito naman si male, dalawang male occurs. So, magiging 11th run. Ito naman si female, nag-iba naman siya. So, nagiging 12th run. And ito, same naman itong tatlong M. So, magiging 13th run. So, the number of runs R is equal to, let's use another, R is equal to 13. Ito. Now, let's count our N sub 1. Since our first event is the male, right? So, let's count how many males occur in this series of events. So, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So our n sub 1 is 10. And our n sub 2, which is female, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So, we have n sub 2 is equal to 10. So, since we already have this data, these values, run is equal to 13, n sub 1 is equal to 10, n sub 2 is equal to 10. Now, our alpha value that we are going to use is 0.05. So, 0.05, it has a table for randomness. So, we will use the table to determine if the series of event is random ba or not. So let's copy first. So, our R is equal to 13. Our n sub 1, n sub 1, and n sub 2 is equal to both 10. Yan. Now, this is the critical values for the run test for randomness. One till the alternative alpha is equal to 0.05. This is the table that we're going to use for the small data. If you're going to ask, mayon mga tanong mo, aning, unsay timailhan nga small data siya. Small data siya if the n1 and n2 is less than or equal to 12. If si n1 ninyo kay di mo lapas og 12 or 12 lang inyong n1 and n2, so n2 po ninyo kay 12, meaning it considered as small data. Pero if malapas na siya 12, large data na siya. So, let's identify if the series of event now is random ba or not by using this table. So, again, our n1 is 10, right? So, this is the n1. This is the 10. And the n2 is also 10. So, ito. Therefore, since n1, ito siya n1, ito. And n2 is ito. Oops. Ito lang. As you can see, there is two values there. The 6 and 16. Diba? So, that values now is our critical region. Therefore, 6 and 16, this is our boundary where 6 must be less than R, and R is less than 16. Therefore, the value of R must be within or in between of this critical region or critical values or the boundary. So since our R is 13 and 13 is greater than 6 and 13 is less than 16 and 13 is within 6 and 16, therefore the series of events is random. That's how we're going to that's how we test the series of events if it is random or not for small data. So let's have our interpretation. So we found that R is equal to 13 and this value is within our critical region since our critical region diba, is 6 and 16 and 13 is within that critical region. Therefore, we do not reject the null hypothesis, suggesting that the sequence of events is random. Therefore, we can state that the order in which the science teacher calls on males and females is random. It implies that the sequence teacher was demonstrating no gender bias in calling students. That is the interpretation. So that's how we test for randomness for small data. Again, first identify the number of runs, the n sub 1 and the n sub 2. If the n sub 1 and n sub 2 is equal or less than or equal 12, it is small data. We will use if it is one-tailed, then we will use the alpha 0.05 table of 0.05. So that's all. Thank you.
So now we will analyze the data from the example earlier using SPSS. So first we need to click the variable view tab at the bottom of our screen, and since we already in the variable view tab, we name our variable gender. Next, we establish a grouping variable to differentiate between males and females since our variable is gender. When establishing a grouping variable, it is often easiest to assign each group a whole number value. First, we select the values column and click the gray square. Then we set a value of 0 to represent male and a value of 2 to represent female. We use the Add button to move each of the value labels to the list. We did not choose the value of 1 since we will use it in step 3 as a reference. Now we click the Data View tab at the bottom of your screen. Then we type the values into the column in the same order they occurred. Remember that we type 0 for male and 2 for females. So that's what we're gonna do now. Use the pull-down menus to choose Analyze, the Non-Parametric Test, the Legacy Dialogues, and Runs. The Runs test required a reference point to compare the events. Under the cut point, uncheck Median and check the box next to Custom. Type a value in the box that is between the events assigned values. For our example, we use 0 and 2 for the event's values, so type a custom value of 1. Next, select the variable and use the arrow button to place it with your data values in the box labeled Test Variable List. In our example, we choose the variable gender. Finally, click OK to perform the analysis. The runs test output returns the total number of observation, which is our n, which is equal to 20, and the number of runs, which is equal to 13. SPSS also calculates the z-score, which is 0.689, and the two-tailed significance, which is our p-value, which is equal to 0.491. In order to determine the number of observations for each event, an additional set of steps is required. Use the pull-down menus to choose Analyze, Descriptive Statistic, and Frequency. Next, we use the arrow button to place the variable with your data values in the box labeled. Finally, click OK to perform the analysis. Based on the result from the SPSS, the runs test indicated that the sequence was random, which result to our runs is equal to 13, our n sub 1 is 10, and our n sub 2 is also 10, and the p is greater than 0.05. Therefore, the science teacher randomly chose between males and females when calling on students. Therefore, we fail to reject our null hypothesis, and that means that the sequence in which the teacher calls on males and females is totally random and doesn't have a pattern.
Good day, everyone. Before we proceed to the formula, let's first understand what a run is. A run is a sequence of identical events or values that occur consecutively in a dataset. It is the basic building block of the runs test and helps us determine the randomness in a sequence. Identifying runs is the first step in performing the test. These formula are used to find the z-score of a runs test for large samples. This formula calculates the mean number of runs in a sequence, where n sub 1 is the number of times the first event occurred, and n sub 2 is the number of times the second event occurred. And this is the formula for the standard deviation of runs. Also, this is the formula for the z-score for a normal approximation of the data. R is the number of runs, and H is the correction for continuity. Ito yung formula na gagamitin para makuha yung H. H is the correction for continuity, which is plus or minus 0.5. So we add 0.5 if the observed number of runs R is less than the expected value. We subtract 0.5 from H if the observed number of runs, which is R, is greater than the expected value. So, muni gamiton pag magkuha og H. Winning formula sa z-score. So, R plus answer sa H minus sa result sa mean over result sa standard deviation. So, muni pagkuha sa sa mga large data samples. So, una is sa mean, sa standard deviation, and the z-score. So, don't forget na tingnan yung kung ano yung H na gagamitin. Is it plus 0.5 or minus 0.5? Sample problem. So, this problem involves analyzing a sequence of observations to assess potential gender bias in student recognition by a male teacher. So, it is based where the observer recorded the gender, male, which is M, and female, which is F, of each student the teacher called on to answer a question. So, over a 30-minute period, the teacher called on 23 males and 14 females. So, ato ang N sub 1 which is 23 and ato ang N sub 2 is 14. So, the sequence of student recognition is provided by the data below. So first, we have to state the null and the alternative hypothesis. So our null is the sequence in which the teacher calls on males and females is random. And our alternative hypothesis is the sequence in which the teacher calls on males and females is not random. Next, we have to set the level of risk or the level of significance associated with the null hypothesis. The level of risk, also called an alpha, is frequently set at 0.05. We will use alpha 0.05 in our example. In other words, there is a 95% chance that any observed statistical difference will be real and not due to chance. So, we have to choose the appropriate test statistic. Since the observer is examining the data for randomness, therefore, he is using a Rand's test for randomness. Next, compute the test statistic. So, if this is the data, pila man ang runs, ang number of runs. So, first, determine the number of runs or it is helpful to separate the events. Diba ang problem kay 23 males and 14 females? So, sila tanan is total of 37 students. So, morning data. And then, atong kanan if pila ka ang runs. Diba ang runs is a sequence of the same event written one or more times. So, pila ka times. So, counted na as 1. So, ito yung example. atong ihapon pila ka runs. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. The number of runs in the sequence is R equals 17. First, we must find the mean and the standard deviation for the data. If kani ang formula sa mean, so i-substitute lang mga values. Diba ato ang n sub 1 is 23 and ato ang n sub 2 is 14. The mean value of runs is 18.4. If this is the formula for the standard deviation, so ganun pa rin i-substitute yung mga values. So our standard deviation is equals to 2.816. If this is the formula for the z-score, so diba ang ato ang R is 17? Pila kaya sa h? Then ang result diba sa mean value of runs is 18.4. Tapos ang result sa standard deviation is 2.816. So before ta mag-answer sa z-score, ato sang i-determine if pila ang correction for continuity or which is h. Recall the correction for continuity if plus 0.5 or minus 0.5. The result shows that 17 is less than 18.4. We choose h is equals plus 0.5. Now, we use our z-score formula with correction for continuity. So, our z-score is equals to negative 0.3196. Determine the value needed for rejection of the null hypothesis using the appropriate table of critical values for the particular statistic. For a two-tailed test with alpha 0.05, we must not reject the null hypothesis. It's because we find that our z-score is within the critical region of the distribution or nasa sa accepted region. Therefore, we do not reject the null hypothesis. This suggests that the order in which the science teacher calls on males and females is random. Interpret the results. We did not reject the null hypothesis, suggesting that the sequence of events is random. Therefore, our data indicate that the order in which the science teacher calls on males and females is random. So, ato ang interpretation ani is the study provides evidence that the science teacher was demonstrating no gender bias. So that's all for the sample runs test, which is the large data samples. Thank you for listening.
Okay guys, so moving on to sample runs test referencing a custom value. So we have the problem the science teacher in the earlier example wishes to examine the pattern of an actress student's weekly quiz performance. A passing quiz score is 70. Sometimes the students failed and other times he passed. The teacher wished to determine if the student's performance is random or not. Table 9.1 shows that the student's weekly quiz scores for a 12-week period. So there is a table 9.1 no makita nato diri ang week 1 to 12 nga score sa isa ka student. So natay 65, 55, 95, 15, 75, 65, 80, 75, 60, 55, 75 and 80. So we have null hypothesis and alternative hypothesis. So for null hypothesis, the sequence in which the student passes and fails a weekly science quiz is random. And for alternative hypothesis, the sequence in which the student passes and fails a weekly science quiz is not random. So setting the level of risk or the level of significance associated with the null hypothesis. The level of risk, also called an alpha, is frequently set at 0.05. We will use alpha is equal to 0.05 in our example. In other words, there is a 95% chance that any observed statistical difference will be real and not due to chance. So in computing the test statistic, the custom value is 69.9. Since the passing quiz score is 70, we must identify which quiz scores fall above the custom score and which quiz scores fall below it. As shown in table 9.2, we mark the quiz scores that fall above the custom score with positive and quiz scores that fall below with negative. Then we count the number of runs. The number of runs in the sequence earlier is R is equal to 8. So our alpha is 0.05. Then giset na to ang custom value sa 69.9 since ang ato ang passing score man is 70. So nagset tag custom value para dali ra na to ma-separate ang passing score o ang failing score. So if ang score sa isa ka week is mula pa siya 69.9, it means nga na siya sa passing score. So positive siya. Then if mo baba siya sa 69.9, it means nga failing score siya. So negative siya. So nag-set patag custom value para ma-avoid po nato nga walay ma-appeal nga score or walay ma-appeal nga week since ang wala man jud kakuhag 69.9 nga score. So makita na to diri sa table 9.2 nga na siya in relation to custom score or sign. So makita na to sa week 1 namatay score nga 65, so negative siya since ang atong custom value man ay 69.9. So below man siya sa 69.9, so negative siya. Then sa week 2 55, so natay negative. Then sa week 3 95, so positive siya. Sa week 4 15, so negative siya. Sa week 5 75, so positive. Week 6 65, so negative. Week 7 80, so positive. Week 8 75, positive. Week 9 60 negative. Week 10 55 negative. Week 11 70 positive. Week 12 80 positive. So mention man rin ang atong R is equal to 8. So equal to 8 siya since nag-base siya sa sequence sa ato ang sign. So makita na to diri ang sequence sa atong sign is negative negative positive negative positive negative positive positive negative negative positive positive. So kung ihapon na to ang ato ang sign nga nagsunod siya nga same lang siya sign is makount man siya as 1. So makita na to diri nga ang una is nagsugod ang duha ka negative, so makount siya as 1. So 1, then next is positive, so 2, then negative, then next is negative 3, then next is positive 4, then next is negative 5, then next is duha man siya ka positive, so makount siya as 1, so 6. Then ang next is duha pod siya ka negative, so makount siya as 1, so 7. Then ang next is duha pod ka positive, so makount siya as 1, so 8. So that's why ang atong R is equal to 8. Then next is since ang ato ang sample size man kay small, so mag-refer ta sa table B.10 sa appendix B. So makita na to dito ang mga critical values. So since ang atong N1 man is 6, then ang atong N2 is 6. So kaning N1 ug N2 is nag-base ni siya sa positive sign o negative sign. So makita na to dito sa 9.2 kung atong ihapon ang positive sign 6 siya ka buok, then ang negative sign is 6 pod. So mo nang ang N1 na to is 6, then ang N2 na to is 6. Then ang atong alpha is 0.05. So makita na to diri ano sa table B.10 sa appendix B. So makita na to diri ang N1 is 6, then ang N2 is 6. So ang ato ang critical region or ato ang acceptance region is 3 ug 11. So within 3 to 11. So since ang atong R man is 8, so nasa sa sulod sa 3 ug 11. So makakonclude ta nga so dili na to i-reject ang null hypothesis. So makakonclude ta nga ang ato ang score, ang weekly score sa katong student is random. So we do not reject the null hypothesis. So nadri ato tong interpretation no? So we did not reject the null hypothesis suggesting that the sequence of events is random. Therefore, we can state that based on a passing score of 70, the student's weekly science quiz performance is random. So reporting the results for this example, the runs test indicated that the sequence was random. So therefore, the evidence suggests that the pattern of the student's weekly science quiz performance is random in terms of achieving a passing score of 70. So I think mo lang to. I hope nga namay nasabtan sa akong report. Thank you.
I am Princess Margia, and I will show you how to perform the runs test for custom value using SPSS. So first thing, we will define the variable. So we will go to the variable view. We will put first rather the data value first. We will type in the value. So we have 65, 55, 95, 15, 75, 65, 80, 75, 60, and wait a minute, let me here 75, 60, 55, 75, and 80. And we will go to the variable view. So we will change the name here. So let's put in quiz. Oh, I'm so sorry for that. We will put here quiz. Let's no cancel. Then we will go back to the data value. So we have here our data now. Then we will analyze data. So we will go to the analyze, non-parametric, then legacy, legacy, then runs. So we will transfer this into the test variable list. Then we will track the custom, not the median. And since our cut point is 70, so we will put 69.9. Okay. Then we have here the runs. So the runs test output
table. So this is the runs test output table. So we have the custom value of 69.9 and the total number of observation is 12 and the runs is 8. And also our z-score is 0.303 and our p-value here is 0.762. So to determine the observation frequency of each event, in order to determine the number of observation of each event, an additional set of steps is required. So we will go to the analyze, descriptive statistic, and frequency. Then we will transfer this into this, then okay. Then we have here our data, the result of the data. So we have here the quiz. So as you can see, the frequency we have 1, 2, 1, 2, 3, 2, 1. So the number of frequency. So to identify the runs, we will count by the changes of frequency. So from 1, so we will start 1 as a 1, then 2 as 2, then from 2 it changes to 1, so we will count that as 3. So 1, 2, 3, 4, 5, 6, 7, and the other one is 8. That then based on the result as the interpretation here. So based on the result, the runs test indicates that the sequence was random since we have the run here as 8 and our n sub 1 and n sub 2 is 6, then therefore since that our p-value is greater than the 0.05, therefore the pattern of students' weekly science performance is random in terms of achieving a passing score of 70. So that's all for the performing the runs test for custom value using the SPSS.